All right, so here we are. We're going to finish off these 6.5 notes. All right, so we did the U-tries. I sent you those out. So we're starting with a factor theorem. All right, the factor theorem says that basically if you get a remainder of 0, that means that this would be a factor of the polynomial. So that's what they're looking at for this, and that's what the factor theorem says. Again, if you divide it by this, and if the remainder is 0, then that means that that was one of the factors for it. All right, so we're going to see how to use that. All right, so what we're going to do is we're going to do example 3. We're going to factor this out. This 2x cubed plus 11x squared plus 11x plus 18x plus 9. Now we are given that f of negative 3 is a 0. Now f of negative 3 is a 0 means this, that x equals negative 3 is a solution of this if it was a 0, or that if we add 3 to both sides, we would get x plus 3 equals 0. So that means that x plus 3 is a factor of this polynomial. So what we're going to do is we're going to take that out of this polynomial and then see if we can factor it. So again, we're going to take it out. We're going to take it out synthetically. So again, we're going to set this up. All right, our negative 3 goes out front. All right, now we have all of our coefficients. So a 2, an 11, an 18, and a 9. All right, now they told us that the remainder is 0, so we better get a 0 here. If we don't, then we know we did something wrong. So start off, we drop this down. We multiply. Negative 3 times 2 gives us negative 6, so we put that up here. We add, which gives us 5. We multiply. Negative 3 times 5 gives us negative 15. And then we add 18, and negative 15 gives us 3. Then we multiply. Negative 3 times 3, which gives us negative 9. And then negative 9 and 9 and negative 9 give us 0. All right, so what we did is we factored that x plus 3 out of this polynomial by doing this. So now what we're left with, we're going to take that, what we're left with, and we're going to see if we can factor that out further. So again, whenever you factor it out, you always drop 1 off this power. So this first term is going to be an x squared. So it's going to give us 2x squared plus 5x plus 3. And now we want to see, can we factor this out? Well, it's got a leading coefficient, so we'll do our box. And we'll put our 2x in the top of each side. Multiply 2 times 3, which gives us 6. And we want the factors of 6 that add up to 5. Well, it is 2 and 3. So 2 and 3. The signs are both the same. They're both plus. The 2x plus 2, we can factor a 2 out of that, which is going to give us an x plus 1. So we got an x plus 1. And then 2x plus 3 on the other side, we can't factor anything out of that, so we leave it as 2x plus 3. All right? Now, it asks us to factor it out. So we factored this part out, but don't forget about the other part that we already brought out of this by doing this. All right? That's that x plus 3. So the factors of this are x plus 1, 2x plus 3, and x plus 3. That if we multiply all these together, we would get the 2x cubed plus 11x squared plus 18x plus 9. All right? So that's what we're doing with this, is factoring it out. All right. Then we can go to our last page of notes. Actually, next to the last page. All right. This is finding the zeros of a polynomial. Again, finding the zeros, what you want to do is this. They're giving you 1 0 is at x equals 2. And they want you to find the other zeros of this. So what we want to do is, again, we want to take this one out. All right. So again, to take it out, we'll do it synthetically. Put our 2 up front. Take all of our coefficients. We're not missing any. So we got a 1, a negative 2, a negative 9, and an 18. We again drop down the first one, multiply, add, multiply, add, multiply, and we knew already we were getting a 0 there. All right, so now what are we left with? Well, remember, it's always one less than this, so this was an x cubed, so that means this is an x squared, so we have x squared. We don't have an x term, and then our constant is 9, so it's x squared minus 9 equals 0. So then we factor that out. That's our difference of perfect squares. So we get x plus 3 times x minus 3 equals 0. So x plus 3 equals 0. So we get x equals negative 3, and x minus 3 equals 0, and we get x equals 3. So the zeros, the other zeros of the function are negative 3 and positive 3. All right, you have this U try. Go ahead and give that a shot. You don't have to pause it because I'm not going to do it. I will send the answer out to you later on. You will get this answer for this problem. All right, but I want you to try that, see if you can do it. Again, they want you to factor it out. All right, so that's like example 3. All right, so factoring out, you're given that k equals 10 is 1, 0 for number 3, and for number 4, you're given k equals negative 5 is a 0 for that. So you got to take those zeros out first, and then factor